Hi, I'm Mike Coleman, a developer advocate here at Google Cloud. In this video, I want to walk you through how you can use Google Cloud's Migrate for Anthos to move existing Linux workloads from virtual machines to containers in just a few steps. This video builds on an earlier one, introducing Migrate for Anthos. If you haven't watched that video yet, definitely go check it out, as this one assumes you perform the prerequisites we outlined there. Building on what you learned in the first video, let's jump into an actual migration. As a brief recap, Migrate for Anthos has three primary components. The discovery tool assesses how successful a migration of a given application might be. The processing cluster is a Kubernetes cluster that is used to examine the source VM and create the migration plan, as well as execute the actual migration. And finally, migctl, a command line tool like kubectl for interacting with the processing cluster. We'll do most of our work today in the Google Cloud console, but I will show you a bit of migctl. And again, to quickly recap, a migration generally consists of the following steps. First, create a Google Cloud project, set up the necessary service accounts, and enable the appropriate APIs. Then you create a migration processing cluster. After that, choose and qualify your target workload. Then you define your migration source, create a migration plan, and adjust that plan to ensure it meets your needs. After that, you create the actual deployment artifacts, and then finally you can deploy the newly containerized application. The first two steps were covered in the previous video, so we'll start by discussing choosing the right workload. There are some applications that are well suited for migration and some that are not. Linux applications that are a good fit for migration using Migrate for Anthos include the following application architectures: web and application servers, business logic middleware, for example, Tomcat, multi-VM, multi-tier stacks, for example, LAMP, small and medium-sized databases like MySQL and Postgres. In addition, applications best suited for migration with Migrate for Anthos have the following operational characteristics. They have a low duty cycle and bursty workloads. They're always on with low load services, or deployment, testing, and training lab environments. In general, most Linux workloads are compatible with migration. However, there are some types of workloads that are not really recommended. These would include high performance and large in-memory databases, VMs with special kernel drivers, for example, kernel mode NFS, apps with dependencies on specific hardware, and software with licenses tied to certain hardware ID registration. For this demo, I'm using a Java application housed in a VM, which also has a Postgres database. So I have a good feeling that this application is an appropriate candidate to migrate, but how can I be sure? Well, we have a utility for that, the Migrate for Anthos discovery tool. The discovery tool has two parts. The first is a collection script that runs on the source VM and analyzes the running application. The analysis script then looks at that information gathered from the collection phase and gives us a score of 1 to 10 on the likelihood of a successful migration. You can run your analysis script on a centralized server, allowing you to batch process collected data. So let's jump into our demo and look at the discovery tool, which I've already installed on the source VM running on Google Compute Engine. You can consult the Migrate for Anthos docs for info on how to install the tool. Before we look at the discovery tool, I wanted to take a quick overview of the sample application we're working with, which is the Symbol Bank app. So I'm going to go ahead and come down here and click sign in. And what you're going to see here is a typical banking application. We're looking at the ledger view here. I can come up and I can click send payment. I can choose another user from the dropdown. We'll use Alice here. I'm going to send her $100 and we're going to click send, and you can see the ledger update. So everything is working the way we expect it to. Let's look a little bit at how that application is deployed on the back end. The application is actually made up of a combination of Kubernetes services and then a monolithic service running in a virtual machine. So on the Kubernetes side, we have 4 services running. They handle everything from managing the accounts database to the web front end we just interacted with, to that drop-down list that we saw where we can pull up associated accounts that the main user has. We come into here, this is our VM that we're going to migrate, and that's the ledger service. So everything you saw there that dealt with the ledger, that is handled here. So how do we update the ledger, check balances, those sort of things. The other thing is that this monolith includes the database, the ledger database. So there's an accounts database and a ledger database, and the ledger database lives inside of this VM. So when we're done, we're going to have migrated this VM into a Kubernetes service. So let's get started with that. So here I am, I've SSH'd into that Ledger Monolith Service VM. And as I mentioned before, I've already installed the Migrate for Anthos discovery tool. So what we want to do here is let's take a look at what that's comprised of. You have the collect script and the analysis script. So we're going to go ahead and run that collect script first. So let me run that. And that's going to produce a tar file here. And we're going to go ahead and then run the analysis script against that tar file. So we'll go ahead and run that. And then that gives us a CSV file. Let's cat out the contents of that file. So this is a little hard to read on the screen. So what I've done is I've actually taken and moved that CSV onto my local machine and loaded it up into a Google Sheet. There's a lot of information here. I'm only going to point out a couple of things. First, our fit score is a 9, and that is right here. So we've got a 9 out of 10, and that means it's a great fit with none to very little manual work based on the glossary here. The other thing I want to point out is that we do have a Postgres database in the VM that the fit tool discovered, and we'll have to deal with that during our migration. But with a score of 9, we should feel pretty good that we should be able to migrate this application with very little effort. So the next step is to actually create a migration source. So we're going to do that by moving back here in the Cloud Console, and we're going to go to Anthos, Migrate to Containers. Remember, we've already set up our processing cluster. We did that in our last video. So the processing cluster is right here. So now we're going to create a source. So we'll come in and we'll say add source. And we're going to select our processing cluster, click next. We're going to go ahead and give this source a name. And it's going to come from Compute Engine. Remember, it can come from VMware or AWS or Azure as well. But in this case, we're using Compute Engine. We'll click next. As in the first video, we created one service account to actually let us install the components on the processing cluster. And now we're going to create a second service account that lets us deal with that compute engine as a source. So we will put the compute viewer and the compute storage admin roles onto this service account. We'll click next, and we'll go ahead and add the source. So we come back here, we have our source all ready for us to go. Next, let's move on and create our migration. Now, one thing to note is that before I can actually migrate a VM, I have to stop it, which I've already done. I've gone into the Google Cloud Console and I've stopped that Ledger Service VM. So it's not running any longer. With that, I would come in here now and I click Create Migration. I take the migration name and I'll give it a name here. We'll come down, we'll select the source that we just created, Linux operating system, and the virtual machine ID is Ledger Monolith-Service. So right there. And we're going to migrate both the image and data. In this case, that Monolith VM has Postgres running in it. So we need both the application code and the data. So let's click Create Migration. This will take a couple minutes. So I'll fast forward the video and I'll rejoin you when it's done. Our migration plan has been generated. So the next step here is now to make sure that migration plan is accurate for what we want to do. So we can come into options and we can review and edit the migration plan. Now, I know one thing I'm going to need to change is down here under data volumes, I need to go ahead and tell it that I want to use the Postgres folder. Right. So we're going to point it at that Postgres subdirectory because remember, we have that database running there in our monolithic VM. So with that, I can save this and generate my artifacts. So let's click Save and Generate Artifacts, and it will save it and it'll start generating the artifacts. Again, this will take a couple of minutes. So I'll pause the video and I'll rejoin you when it finishes. So the migration is completed and our artifacts have been generated. I can click on the link of the migration here and click on the artifacts tab and you can get a list of all of them. So we have a Docker file, but the Docker image has actually already been created and uploaded to container registry for us. So we don't need to do anything with that. What we really care about is this deployment spec. Now there's a couple ways you can grab the deployment spec or any of the artifacts for that matter. One is they're stored in a storage bucket up on Google Cloud Storage. And you could download them from here. The other way to do it is to use migctl, the command line utility, and that's what we're going to do. So I'm going to move over into Cloud Shell and I'm going to issue a migctl migration get artifacts command, and that's going to download the artifacts for me. So let me go ahead here and I'll list out the deployment spec.yaml just to verify it got downloaded. And that's a standard Kubernetes YAML file for deploying the service and some other stuff. We're not going to spend a lot of time going into that, but what we are going to do now is actually apply it. Now, the processing cluster is different from the production cluster where I run my applications. So I need to actually authenticate into that production cluster. So let me go ahead and issue the gcloud command to authenticate into my production cluster. And we will list out the nodes just to make sure I have the right cluster. And I do. So the next step is to actually just do a kubectl -f apply and apply the deployment spec. And that's going to create a stateful set. It's going to create a service, a persistent volume, and a persistent volume claim. The persistent volume and the persistent volume claim will be used to handle that Postgres database we migrated over from our monolith VM. The next thing we need to do is ensure all of the services can find each other. The symbol bank app does this through a set of configuration variables. Currently, the variables associated with the Ledger service are pointing to the compute engine internal DNS name of the Ledger monolith VM, which has the format of instance name.c.projectid.internal, which you can see right here. I'm going to swap those out for the Kubernetes service name, which is simply Ledger monolith-service. And if I list my Kubernetes services, you can see that service listed right here. So the next thing to do is actually apply that config map so those new service mappings take place. So we'll apply the config map here. Next, let's go ahead and delete all the existing pods, and that will force them to pick up the new mappings when they regenerate. And after that, what we're going to do is we're going to list our services so we can grab the IP address of our front end and check out and make sure the application is still working as expected. So I'll copy this. And I'm going to paste it up here into my browser. So the symbol bank app has loaded. Let's sign in again. So we're signed in. Here's the ledger. Let's go ahead and do a send payment to Alice again. Let's give her $250 this time. And we'll click send. And we can see the ledger is updated. So our application is working exactly as we expected to after a successful migration. So there you have it. In this video, you learned about using Migrate for Anthos to move Linux workloads into containers, including how to assess your application, create the migration plan, execute the migration, and deploy your newly containerized application. Be sure to like and subscribe because we'll be posting subsequent videos in this series to cover topics such as best practices for evaluating your application, how to migrate Windows workloads, and more. To get started with Migrate for Anthos today, visit cloud.google.com/migrate/Anthos.